Given that x equals -4 is a real root of f of x equals x cubed plus 3, x squared minus 16x minus 48, use long division to find the other roots and write the polynomial in factored form. So we'll be working through examples just like this through this video. Alright, so x minus 4 is a real root. That means x plus 4 has to be a factor. So we'll do a little long division to get another factor, and then to work our way towards getting the roots. So I'm going to take this x and divide it into this x cubed. Another way of looking at it is saying what times x would give me x cubed. That will be x squared. So that's x squared times x gives me x cubed. X squared times 4 gives me 4x squared. Right, so when I subtract, I like to put this in parentheses to remind myself to subtract this second term. So the first term should always cancel. But make sure you don't get your sign messed up here on this one, because it's 3 minus 4. So 3x squared minus 4x squared give me a negative x squared. And then I'll go ahead and bring down what's next. And to keep track of it, I'll go ahead and bring this down with it. Some people choose to wait to bring this last term down. All right, so then I'm looking at this x and this negative x squared, and I know that negative x times x would give me negative x squared. And I'll subtract. And negative 16 minus negative 4, so I already knew those first terms would cancel. I would get a negative 12x, and I'll bring down the negative 48. And that leaves me with minus 12 up here, because negative 12 times x gives me negative 12x, and negative 12 times 4 gives me negative 48. Subtract those, and I get 0. So I know that x plus 4 is the factor when I get my remainder to be equal to 0. Always, always, always happens that way. And it's important that you understand why that happens. So if you have, let's just go back to plain old regular numbers. If you have 100 and you want to divide it by 3, then you would have 33, and then it'd be 0.3 repeating, or 33 with a remainder of 1. There's a remainder because 3 does not go into 100 evenly. 3 is not a factor of 100. 4 is a factor of 100. 5 is a factor of 100. There are plenty of factors of 100, but 3 is not one of them, so that's why you have a remainder. It doesn't go in evenly. That's the same type of thing when we're talking about up here. X plus 4 is a factor of this x cubed plus 3x squared minus 16x minus 48 because it divides into it evenly. If you multiply x plus 4 times x squared minus x minus 12, you'll get back to all of this in here in the dividend. So that's how you know it's a factor. Factor still means the same thing today that it did when you learned it in elementary school when you were making factor trees. Alright, so this is factored, but we can factor it even more because this quadratic part right here, it factors. I know that it factors because I take this 1 that's in front of the x squared that we don't see, and I multiply it times negative 12, and I get negative 12. So I'm looking for numbers that multiply to get negative 12 and add to get negative 1. And negative 4 and 3, they definitely add to get negative 1. Since there is the coefficient of x squared here is just 1, I can do a little shortcut. I know this is just going to be x minus 4 and x plus 3. Little shortcut. And I just bring the rest of it down. So factored form, right here. Completely factored. Alright, now to get the roots, also known as the zeros, In this case, they'll end up being x-intercepts since they're real, sometimes called solutions. Lots of words mean pretty much the same thing. I'm going to set this equal to 0. When you're looking for zeros, you should set it equal to 0. Set the equation equal to 0. Alright, because of the whole zero product property rule thing, when it says that if you want 0 for an answer and you're multiplying things, so we have 3 big things here that we're multiplying, if any of these are 0, then that's how we would get 0 for an answer. So the zero product property. So what we do is we set each one of our factors, the 3 factors, equal to 0, so we can get the different possibilities to make this multiplication problem equal to 0. So we have x equals -4, so I just subtract the 4. I add the 4, and I get a -3 over here. So there are my 3 roots. The one that I was given, and then the other 2. Alright, so now you're going to try a problem. Given that x equals 1 is a root of f of x equals 4x cubed minus 5x squared minus 2x plus 3, use long division to find the other roots and to write the polynomial in factored form. So here I've used long division, and I've gotten x minus 1, and when it's divided into this cubic polynomial, 4x squared minus x minus 3. And then I factored the quadratic, and I have the factored form. So because x minus 1 was listed twice, you can write it as this quantity x minus 1 squared times the quantity 4x plus 3. Now, when you are actually finding your roots, your zeros over here, you do not have to list out the x minus 1 twice because you're going to get the same answer. But you do have the root x minus 1 with a multiplicity of 2 because it's listed twice. And then x equals -3/4 with a multiplicity of 1. So you have 3 roots. It's just 2 of them happen to be the same. And remember, graphically, what that will look like is that x equals 1. The curve of the function, so the actual graph of the function, it's not going to pass through the x-axis. It's going to change directions right at x equals 1. Alright, let's try another example. Given that x equals 2 is a root of f of x equals x cubed plus 2x squared minus 8x minus 16, use long division to find the other roots and to write the polynomial in factored form. Alright, if x minus 2 is a root, then x plus 2 is a factor. So let's set up the problem. And then I'll start dividing. The first step is to, plug, or to see what times x would give me x cubed. So that would be x squared. So x squared times x is x cubed. X squared times 2 is 2x squared. When I subtract, that actually all cancels out. So I don't have anything here, and I'll just bring this stuff down. So I have -8x. Make sure you remember that negative. Always takes the sign in front of it. Right? And then here I would have a -8 because -8 times x is -8x. And then minus 16. Alright, so in factored form here, got it in red, f of x equals x plus 2, and then x squared minus 8. So I have to think, is there anything that multiplies to get -8, because I have to do AC, -8, that would add to get 0. and there isn't anything, because the factors of 8 are just 1 and 8 and 2 and 4. So there's nothing, this can't be factored anymore. Can't factor this part of it. So we have it in factored form. So then now we can find the roots. So I'll set this equal to 0. Equation is equal to 0. Alright, so I set each factor equal to 0. And solve. So here's that -2 that I started with. -2. And then over here, I'll add the 8. Take the square root of both sides. And I have a positive or negative square root of 8. Now, I do want to check to see if I can simplify the square root of 8, and I can. I know that I can simplify the square root of 8 because a perfect square does go into 8, which would be 4. So the square root of 8, I'll bring this up here. Square root of 8 has 4 that goes into 8, so that's like the square root of 4 times 2. So that's like the square root of 4 times the square root of 2. Square root of 4 is 2. Square root of 2 is 1 point stuff. So I have 2 square roots of 2. So all of this, just a little, I should make a thought bubble of what I'm doing as I'm trying to simplify this. So I have x equals a positive 2 square roots of 2, but you don't really have to write positive. It's assumed to be positive. Just like other numbers, you don't write positive in front of. And x equals a negative 2 square roots of 2. And then we had x equals -2. So this is cubic, so we know that there are going to be 3 roots, and these are the 3 roots. They are all real numbers, even though these 2 are irrational. They're still real, so we have 3 x-intercepts. So 3 roots, -2, 2 square roots of 2, and -2 square roots of 2. All right, now it's your turn to try a problem. Given that x equals -3 is a root of f of x equals x cubed plus 3x squared minus 7x minus 21, use long division to find the other roots of the polynomial function and to write the polynomial in factored form. The form is right here. So using long division, when you divide x plus 3 into our cubic polynomial expression here, you get x squared minus 7. So in factored form, you have x plus 3, that quantity, times quantity x squared minus 7. Then when you are solving for the roots, you get your original -3 back from the problem. And then you have a positive square root of 7 and a negative square root of 7. And you cannot simplify the square root of 7 because there is not a perfect square that divides evenly into 7. Alright, let's try another problem. Given that 2x minus 7 is a factor of f of x equals 2x cubed minus 7x squared plus 18x minus 63, find the roots. Okay, so let's divide. So the directions change just a little bit, but nothing that we're going to do is really going to change. Okay, so this 2x goes into 2x cubed, x squared times. So in other words, x squared times 2x gives me 2x cubed. X squared times -7 gives me -7x squared. Right? This all makes 0, so I'll just bring down 18x minus 63. And it would be 9 times 2 to get 18. So 9 times 2x to get 18x. 9 times -7 to get -63. And when I subtract that, I'll get 0. So for factored form, I'll start with 2x minus 7 and x squared plus 9. And I already know that x squared plus 9 is not going to factor, because there's nothing that you could multiply to get 9 and then to add to get 0. Because even if you did 3 and 3, if you added those together, you get 6. Negative 3 and negative 3 would get negative 6. So you can't, this is complete factor form. So what I'll do then is go ahead and define the roots of the zeros, is I'll set each factor equal to 0. Skipping a step, so I would set the whole equation equal to 0. Then I would set each factor equal to 0. Alright, over here in solving this, I would add the 7 over and then divide by the 2. So x equals 3.5. This decimal is okay because it's it can be written as a fraction. It's rational. So it doesn't continue to repeat without any type of pattern. So then when I'm over here to solve for x, I'll subtract 9 on both sides, and then take the square root. So when I take the square root of negative 9, all the way back up, when I take the square root of 9, I would get 3. That would leave a negative 1, and the square root of negative 1 is I, represented by I. So I have 3 roots. I have to, since this is cubic, the degree is equal to 3. And my roots are 3.5, 3i, and negative 3i. Right, and now it's your turn to try a problem. Given that x minus 1 is a factor of f of x equals x cubed minus x squared plus 64. X minus 64, find the roots. Here you can see where I divided to get the x squared plus 64, wrote it in factored form, and to find the zeros, or the roots, I set f of x equal to 0, and then I set each factor equal to 0, and my roots were 1 and a positive and negative 8i. So this cubic polynomial has 1 real root and 2 roots that are not real. So that means it has 1 x-intercept. And that concludes this video.